Okay, so the next thing that we have here is exercise 15.1, and question number 1 here is we want to find the mean deviation above the mean for the data in these two exercises 1 and 2. So we want to find the mean deviation about the mean, which is x bar, for this data, and the data is 4, 7, 8, 9, 10, 12, 13, and 17. So you want to find the mean deviation about the mean for this data. So in order to do that, so of course you know that the mean deviation about the mean, the formula for that is the mean deviation about the mean is equal to sigma f of I times the absolute value of x of I minus x bar over sigma f of I. So if you calculate this, that gives you the mean deviation about the mean. And we have already talked about the concept. You know already what that means. So now in order to calculate this part, I need a simple table. Although the data is not that complicated, but it doesn't hurt to have a table over here. So I can basically create this table. I can call these observations, I can call them x of I. And then the frequency of those observations, I can call them f of I. And then, so you have 4, 7, 8, 9, 10, 12, 13, and 17. And then the frequency of each of these observations is 1. So you have 1 over here, 1, you have a 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 1, and a 1. Now, sigma, basically, for this formula, I also need my x bar. And you know that basically x bar is the same thing as basically sigma f of I times x of I divided by sigma f of I. And of course the mean of this data is just the sum of all the observations divided by the number of the observations, meaning that, for example, you can say the mean of this data is going to be, this thing over here is going to be basically 4 plus 7 plus 8 plus 9 plus 10 plus 12 plus 13 plus 17 divided by the number of them, which is 1, 2, 3, 4, 5, 6, 7, and 8. It happens, as it happens, basically this is equal to 11 plus 8 is equal to 19, 19 plus 19, and then you have a 25 and a 17 here. So that's 19 plus 12 is 19 plus 12 is this is supposed to be 80. This is actually supposed to be 80. So this is 11 plus 8 is equal to 19, 19, 12, 13 is 25, 19, 19, 25, and 17. So this is 27. I don't understand. I calculated all of these. 8 plus 9 plus 10 plus 12 plus 13 plus 17. This is 80. So okay, so let me see. 19 plus 19 plus 25 plus 17 is equal to 80. Uh, 2 times 9 is equal to 18. I see, that is 18. 2 times 9 is equal to 18. 18 plus 12 is equal to, of course, 30. We have 3 over here, and then 3, 4, 5, 7, and 8. So that's an 80. So that's the same thing as 80 divided by 8, which is equal to 10. So your x bar is equal to 10, right? Your x bar is equal to 10. Your x bar is equal to 10 here. So you don't have to worry much about that. So now what I need is x sub I minus x bar. X sub I minus x bar, and take the absolute value of that. And then we need to calculate f of I times this, which we will do in the next step. So x sub I minus x bar is equal to 10. 4 minus 10 is equal to negative 6. So that's a positive 6 in the absolute value. Positive 3, positive 2, positive 1, 0, and a 2, and a 3, and a 7, right? And then if I write f of I times the absolute value of x sub I minus x bar, that will give me basically 1 times this, 1 times this, and so on and so forth. So you will get the same numbers: 6, 3, 2, 1, 0, 2, 3, and 7. And then if over here, if I calculate sigma f of I times the absolute value of x sub I minus x bar, that gives me basically 9 plus 2 is equal to 11, 12, 14. 14 plus 3 is equal to 17. 17 plus 7 is equal to 24. Is equal to 24. And sigma f of I is equal to basically 1, 2, 3, 4, 5, 6, 7, and 8. So now the mean deviation above the mean is equal to basically sigma f of I times the absolute value of x of I minus x bar, which is equal to 24 over 8, which is equal to 3. So the mean deviation above the mean in this case is 3. Now as another example, let's say that you have this data over here. You have 38, you have 70, you have 48, you have 40, you have 42, you have 55, you have 63, you have 46, you have 54, and you have 44. And you have 44. So if I write my data in a table, because I want to find the mean deviation about the mean, if I write my data in a table, I could write my observations as x sub I, and then the frequency of them as well. So 38, for example, happens once. Then 40, 42, then you have 40, 42, 40, 42, and then you have 46, 44 and 46, 44 and 46, then you have 48, then you have 48, and you have 54, 55, you have 54 and 55, you have 63 and 70. You have 63 and 70. So the frequency of each of these observations is 1, 1, 1, 1, 1, 1, 1, 1, 1, and 1. Now you want to find the mean deviation. you want to find the mean deviation about the mean, right? So the mean deviation about the mean is equal to sigma f of I times the absolute value of x of I minus x bar over sigma f of I, right? So over here I need my x of I and x bar, so I need to calculate first my x bar. Now the x bar, if you want to calculate it, you can just simply add all of these numbers together. Okay, so now in order to calculate my x bar here, what I need to do is just add these numbers together. So you can do it using a calculator if I don't want to do it myself, so I will use a calculator. For example, 38 plus 70 plus 48 plus 40 plus 42 plus 55 plus 63 plus 46 plus 54 plus 44 is equal to 500. And the number of these observations is 3, 6, 9, and 10. So 500 divided by 10 is equal to 50. So that means that your x bar is equal to 50. Now if your x bar is equal to 50, then you can calculate x of I minus x bar and take the absolute value of that, x of I minus x bar, and that would be equal to basically, for example, 38 minus 50, which is equal to negative 12, so you'll get 12, negative 10, 10, negative 8, 8, negative 6, 6, negative 4, 4, negative 2, 2, 4, 5, 13, and 20. And then if you multiply basically f of I times the absolute value of x of I minus x bar, you will have to multiply by one by each of these numbers. You'll get the same numbers: 12, 10, 8, 6, 4, 2, 4, 5, 13, and 20. And then if you want to take the sum of all of these numbers, you will get sigma f of I times the absolute value of x of I minus x bar, which is basically the sum of all of these numbers. This is 22. 22 plus 8 is equal to 30, 40, and 40 plus 46, 46, 51, 61, 64, and 84. And 80. Oh, I'm sorry, I was talking and I was not recording, so I don't know where I left the video, but I think that basically sigma, x bar, you can calculate it using basically by adding all of these numbers together, dividing by the number of those numbers. That gives you 50. And then you can calculate basically the absolute value of x of I minus x bar, which is x of I is basically this value, x bar is this value. Do the subtraction and take the absolute value of that. That gives you these values. And then you need to calculate f of I times the absolute value of x of I minus x bar, which will be basically 1 times 12, 1 times 10, and so on and so forth. Essentially the same values. And now if you calculate sigma f of I times the absolute value of x of I minus x bar, meaning all of these values added together, that will give you an 84. Sigma f of I will give you 10. 84 divided by 10 will give you 8.4. That is the answer there. So that is this example. Now, question number 3 and 4 are about finding the mean deviation about the median. Finding the mean deviation about the median m, right? So for example, the data that you have is basically 13, 17, 16, 14, 11, 13, 10, 16, 11, and 18, and 12, and 17. This is the data that you have. So 13, 17, 16, 14, 11, 13, 10, 16, 11, 18, 12, and 17. So you want to find the mean deviation about the mean for this data. So the mean deviation about the mean is equal to basically sigma f of I times the absolute value of x of I minus the median divided by sigma f of I. So what I need here is basically, first I need to find the median of my data. The median of my data is, you can find the median of this data pretty easily by this method, because there is nothing really, I'll show you what I mean by that. So if you basically arrange this data in a simple table, and here you write your x of I, meaning all of these observations. So you see that you start with a 10 and an 11. So you have a 10 over here. You have a 10 over here which occurs one time. So this is f of I, for example. You have 11 which occurs twice. So you have 1 and 1, so twice. You have a 13 that occurs 1 and 2 times. So you have a 13 that occurs 2 times. But then you have 12 as well. You have 12 as well that occurs 1 time. Right? So I have 10 which occurs 1 time. I have 11 that occurs twice, and I have 12 that occurs once, and I have 13 that occurs twice. So I have 13 and 13 over here. Then I have 14 which occurs once. Then I have 16 that occurs twice. So 14 once, 16 twice. Then I have 17 that occurs twice, and then I have 18 that occurs once. I have 18 that occurs once. Now the median of this data is the observation that comes exactly in the middle of your observations. So in order to find out what that observation is, you need to know how many observations you have in total, meaning that you need to calculate sigma f of I, which is equal to, you can take it as lowercase and uppercase, and doesn't really matter. It's 3, 4, 6, 7. 7 plus 5 is equal to 12. So that's 5, 6, 6, 8, 9. 9 plus 3 is equal to 12. So since this is an even number, you will get basically 2 medians. When you have an even number, you have basically the median is calculated by n divided by 2th observation, and n divided by 2 plus 1th observation. So n divided by 2 is basically the 12 divided by 2, which is the 6th observation, and that is the 7th observation. So the sixth observation would be, of course, you can use the cumulative frequency of these classes. You can add cumulative frequency, and then you have basically 1 plus 2 is equal to 3, 4, 6, 7, 9, 11, and 12, right? So now I know that, for example, all the way up to the third observation, my basically I have all the way up to the third observation, I have my observations over here, or all the way up to the fourth observation, this is the fourth observation. All the way up to the sixth observation, this is the observation, and so on and so forth. I'll show you how you can use this table as well, meaning that, for example, I'm looking for my sixth observation. My sixth observation is exactly over here, which is 13, right? Which is 13. And so that's basically how you find your sixth observation, that is 13. My seventh observation is right over here, which is 14. Now, since I got two medians, 13 and 14, I have to take the mean of these two observations in order to get just one median. And the mean of these two observations is going to be 13.5. So that means that the median of my data, is equal to 13.5. Now what this means is that the value of the observations that I have here, about 50% of those observations fall below 13.5, and about 50% of those observations fall above 13.5. That's the meaning of the median. Now you can, of course, then use this idea in order to make sense of different situations depending on where your data basically comes from. So now that I know the value of my median, I can calculate, for example, x of I minus m, and the absolute value of that as well, of course. So x of I minus m is equal to, for example, 10 minus 13.5, so that's 3.5, negative 3.5, in the absolute value 3.5. That's 2.5, that's 1.5, that's 0.5, that's 0.5, that is 16, 13, 2.5, that's 3.5, and 18, 4.5. So this is x of I minus m. Now if you want to, now you need to calculate f of I times the absolute value of x of I minus m, which is basically, for example, 1 times 3.5, 2 times 2.5 is 5, 1 times 1.5 is 1.5, 2 times 0.5 is 1, 0.5, 5, 7, and 4.5. Now the sigma f of I times the absolute value of x of I minus m, sigma f of I times the absolute value of x of I minus m, is the sum of all of these numbers, which is basically 8.5, 9.5, 10, 11, 11.5, 16.5, 16.5, 17, 21, and 28, I suppose, if I'm not mistaken. Let me check. So that's 3.5, 5, 1.5, 1.5, 5, 7, 4.5 is 28. So now I have basically sigma f of I times x of I minus the absolute value of x of I minus m, and I also have sigma f of I. So then I can write basically this as 28 divided by 12, which is equal to divide by 4 times 7 is equal to 28. 4 times 3, that's 7/3, which is the same thing as 2 point something, which is 2.33, which is approximately 2.33. So the mean deviation about the median is 2.33 in the case of example number 3. 2.33. Okay, so now let's say that we have another set of observations, like for example 36, 72, 46, 42, 60, 45, 53, 46, 51, 49. Okay, so we have this set of observations, and we want to find the mean deviation about the mean. The mean deviation about the mean of this data. So first I need to find the mean of this data. So again, to find the mean of this data, it's not really required to use any formulas or anything. You can just simply, of course, you know that the mean deviation about the mean, you can calculate it by sigma, basically f of I times the absolute value of x of I minus m, which is the mean, and then divided by sigma f of I. So first I need to calculate my mean. Now in order to calculate my mean, the median, not the mean but the median, I can write my x of i's over here, and those are basically, and I need to write them in ascending order, for example. So I have 36, occurring once. I have then I have 42, 45, 46. Then I have 42, 45, 46. So 42 is basically 1 and once. 45 is again once. 46 is twice. And you have then 46. In 40s, basically you have 49 once. Then you have 51. You don't have 50, you have 51 once. And then you have 53 once. And then you have 72 once. And that's it. So 1, 2, 3, 4, 5, 60. There is also 60, I'm sorry. There is also 60 once and 72 once. 60 once and 72 once. So in total I have basically 1, 2, 3, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 observations, and this is the frequency of those observations. So next, what I need to do, I want to find the median of this data. So we said that this was basically the sigma f of I was equal to 5, 6, 7, 8, 9, 10, that means that the number is an even number. So when your number is an even number, n divided by 2, n divided by 2th observation and n divided by 2 plus 1th observation are the medians, and then you have to take the average of those two. So that means that if n is equal to 10, that means that 10 divided by 2, the 5th observation and the 6th observation. Now the 5th observation, it's easy to calculate it here, otherwise you would do the cumulative frequency of these classes. It's not really required here. So 1, 2, 3, 4, 5. So this is your 5th observation, which is 46. And your 6th observation is 1, 2, 3, 5, and 6. So that's 49. Now 46 plus 49 is equal to 46 plus 49 divided by 2 is equal to 15. So 95 divided by 2, which is equal to 47.5. So the mean of your data is 47.5. So now that I have the mean of my data, I need to calculate the mean deviation about the mean. I'm sorry, now that I have the median of my data, this is the median, not the mean, I'm sorry. Keep saying mean. Now that I have the median of my data, I need to find the mean deviation about the median, right? So then the next thing that I need to calculate is the absolute value of x of I minus m. And so that would be basically x of I minus m. So 36 minus 47.5 is basically 11.5. So 47.5 minus 36 is equal to 0, 1, and 1. Actually 5 over here, so that's 11.5. That's negative 11.5, which becomes 11.5. 42 minus 47.5 is 5.5. In the absolute value becomes positive. So that's 2.5 again, that's 1.5. That's 49 minus 47.5 is 2.5. 51 minus 47.5 is 4.5, I suppose. 51 minus 47.5, I don't want to make mistakes. So it's basically a 4 and a 10 and a 10, so that's a 5, and that's a 3, that's a 3.5. 3.5. So you have 51 minus 47.5 is 3.5. 53 minus 47.5, you have 3 over there and 2.5, so 5.5. 60 minus 47.5, you have 2.5, so that's 12.5. And 72 minus 47.5, you have 12 over there and 2.5, that's 14.5, I suppose. 14.5, I want to check. So you have 72 minus 47.5 is 24.5. 24.5. Okay. 24.5. So these are basically this is the absolute value of x of I minus m. Now if you calculate f of I times the absolute value of x of I minus m, that gives us basically 11.5. What is 36 minus 47.5? negative 1, that's 1.5. It's supposed to be 1.5. And then 1 times 1.5 is 5.5, 2.5. You have 3 over here. You have 2.5 over here. You have 3.5 over here. You have 5.5 over here. You have 12.5 over here, and you have 24.5 over here. And if you take the sigma of, basically add all of these together, you have the sigma of f of I times the absolute value of x of I minus m. So that's equal to basically 6, 7, 9, 9.5, 12.5, 14.5, 15, 18, 18.5, 23.5, 24, 24, and then you have 36.5, and then you have 56, 60.5, 61, I suppose. That's equal to 61. So I do it again. So 24.5 plus 12.5 is 36, 37. And then you have 5.5, 3.5 is 8, 9, 11.5, 14.5, 16, 17, 17, all the way up to here. And then you have 6 and 7. That's a 21. And then you have a 61, that's a 61. So sigma f of I times the absolute value of x of I minus m is equal to 61. And sigma f of I is equal to 10. So 61 divided by 10 is equal to 6.1. That's the mean deviation about the mean, which is question number 4. And there is something wrong here, I suppose. We will go and check. So let's see. You have x of I minus m. X of I minus m. Let's see if we can find some website or something to find, for example, the median of some data. Let's see if we can find that. So average calculator, mean calculator, soup. There is usually good calculators here. And here average or mean, I'm sorry, the median. If you go to statistics, mean, standard deviation, mean, median, mode calculator. So here if you go for, okay, so if you enter your data here, and your data is basically, for example, 36, what happened here? I don't understand. Okay, so now your data is basically, for example, 36. I think you have to separate them using spaces, I suppose. 72, 46, 42, 46, 42, 60, 45, 53, 46, no, let me see, 36, 72, 46, 42, 60, 45, 53, 46, 51, 49, 51, 49. And if you calculate here, it will give you the median as 47.5. 47.5, which is correct, right? The median is correct. Now, what we need to do is now find x sub I minus m. And I think they have made some sort of mistake over here in calculation. So, for example, 36 minus so what you can do, in order to simplify your calculation here, for example, you see that your m is equal to 47.5. Now, I want to calculate all of these calculations are x sub I minus m. And for example, that would be 36 minus 47.5, 42 minus 5. So there's a 0.5 here, which is a nuisance. You want to get rid of that. So whenever I want to calculate, I simply calculate, for example, 36 minus 47, and then add the 0.5 back in the end. So for example, 36 minus 47, I know it's equal to 11, negative 11. So 36, for example, minus 47 is 47 minus 36 with a negative sign, 1 and 1, that's negative 11, and then that's 11.5. So that is 11.5, and I think I had written the right value here, but then somehow we got it wrong. And I think the other values must be right. So let's try with this value corrected. Now, if I find the sigma of all of these values, the sigma of all of these values would be 11.5 plus 5.5 plus 2.5 plus 3 plus 2.5 plus 2.3 plus 2.5, 2.5 plus 3.5 plus 5.5 plus 12.5 plus 24.5 is equal to 71. 71. It gives you 71. That was basically the 10 that we added in here. 71, and then if you calculate 71 divided by 10, that gives you 7.1, of course. Now the value that has been calculated in the book is 7. Let's take it as, well, approximation, let's take it as right. It's not that important. You understand the process, of course. Here and there, sometimes I can make mistakes, but well, that's not that big a deal, because the good thing about basically mathematics is that when you make a mistake, you can always, of course, you can always catch yourself, so that's not a problem. But of course, it's not, I mean, you're not supposed to make a habit out of making mistakes. That's not a good thing either. Okay, so the next problem that we have is a problem that I tried to solve, but I made a mistake and I couldn't find the mistake. So let's do it again. So you have basically 5, 10, 15, 20, 25. Let me do it all over again. I don't want to confuse myself. So the data that you have is basically this data. So you have your x sub i's here. Let's see that this is your x sub i's, and those are 5, 10, 15, 20, 25. 5, 10, 15, 20, and 25. And the frequency related to these observations are 7, 4, 6, 3, 5. 7, 4, 6, 3, and 5. And so what we want to do is actually we want to find the mean deviation about the mean. The mean deviation about the mean for this data. So now in order to do that, you know that this is equal to basically sigma f of I times the absolute value of x of I minus x bar over sigma f of I. So first I need to find my x bar. And you know that x bar is equal to basically sigma f of I times x of I. This is the direct method, divided by sigma f of I. So if I calculate f of I times x of I over here, what I will get is 5 times 7 is equal to 35, 4 times 10 is equal to 40, 6 times 15 is equal to 90, and 3 times 20 is equal to 60, 5 times 25 is surprisingly not, 5 times 25 is, okay, 5 times 25 is actually 125. Okay. Okay, so now in order to calculate the mean of this data, we need to calculate sigma f of I x of I. So sigma f of I x of I is equal to sigma f of I x of I is equal to basically, here you have 75, and then you have 150 plus 125. 150 plus 125. So you have 0 over here, 1, and then 12, 14, 15, 1, and 350. That is 350. And sigma f of I is equal to all of these numbers added together, which is 11. 11 plus 6 is equal to 17. 17 plus 3 is equal to 20, 25. So then the mean of your data is going to be equal to 350 divided by 25, which is equal to 1 times 25 is 25. That is 0, 0, and 100. 4 times 25 is equal to 100. Let me see, I don't know why I'm making a mistake here. 35 plus 40 plus 90 plus 60 plus 125 is 350. 350 divided by 25 equal to 14. Now 7 plus 4 plus 6 plus 8 equal to 25. Based on what I saw over here on this website, the mean of this data must be 14 correct. Is 14 correct? Okay. So now the mean of the data is 14. That is equal to 14. Now then what you need to do is basically find basically the absolute value of x of I minus x bar, which is basically, for example, 5 minus 14, which is equal to negative 9. So it becomes positive 9 in the absolute value. 10 minus 14, negative 4, positive 4, 15 minus 14, 1, 20 minus 14, 6, 25 minus 14 is equal to 11. And so if you multiply f of I times the absolute value of x of I minus x bar, you will get basically this column times this column would be 63, 16, 6, 18, and 55. Now sigma f of I times, so this expression up here would be sigma f of I times the absolute value of x of I minus x bar is equal to, well, 16 plus 6 is equal to 22. That's equal to 22, so you have 63 and 22. You have 18 and 55. So you have 5 plus 5 is equal to 10, 18, 1. 5 plus 18, 1. And then you have 7, 9, 10, and 15, 158. That is equal to 158. So then you have 158 divided by sigma f of I. So sigma f of I is equal to 25. Is equal to 25. So that means that then this thing over here is equal to sigma f of I times the absolute value of x of I minus x bar over 25, which is equal to 158 divided by 25. 158 divided by 25 is equal to, well, 5 times 25 is equal to 125. 6 times 25 is equal to 120, and 30, 150. So 6 times 25 is equal to 6 times 5 is equal to 33. 12 plus these are 15, so that's an 8 remainder. And then you have 0 here, a decimal point is 0, and 3 times 25 is equal to 75, I'm sorry, 75, 5 remainder, and 0 is 0, so then you have 2 times 25 is equal to 50, so that's 6.32. 6.32, which I believe is the right answer. 6.32 is the right answer.